Gujarat Technological University, Chandkheda, Ahmedabad affiliated. Our college name is the BHRUV College of Engineering and Technology from Rajkot. This is users defined project report. Our project name is the Assessment and Experimental Analysis of Construction and Demolition Waste into Construction Soil. A project report submitted to Gujarat Technological University in partially fulfillment of requirements for the degree of Bachelor of Engineering in Department of Civil. Academic year is 2020 and 21. Submitted by GOSWAMI DHRUV. His enrollment number is 180043106001. Second member is Chotalia Nirav. His enrollment number is 170040106003. Third member is Mehta Yash Kumar. His enrollment number is 100043106010. This project is guided by Professor Rahul Parmar. He is a faculty of BHRUV Engineering and Technology, and head of department is Dr. Vimal Patel. Sustainable construction waste management. India is urbanizing faster than its urban planners can handle. We are building roads, bridges, flyovers, factories, commercial complexes, and also building and renovating our homes and residential properties. Sometimes to upgrade the buildings or to take advantage of higher FSI regulation now allowed in many cities. But we do not pay sufficient need to the construction and demolition waste we generate. For example, bricks, concrete, stone, hardcore subsoil, topsoil, timber, glass, gypsum, ceramic, and also plastics. Neglecting this waste has consequences for public health as well as the environment. There is no agreement on the volume of construction and demolition waste. The Ministry of Environment, Forest and Climate Change in 2010 put the annual estimate of construction and demolition waste at 10 to 12 million tons. The Central Pollution Control Board settled for 12 million tons in 2011, but it is guideline document of 2070 has upped to estimate to 25 to 30 million tons based on information from the Ministry of Urban Development. The Center for Science and Environment switched to the other extreme and estimated construction and demolition waste at a homogeneous 530 million tons for 2013, as they include the waste from renovation repairs, assuming that one third of the existing stock of buildings carried out renovations or repairs in 2013. The most recent annual estimate of construction and demolition waste in Indian cities is 165 to 175 million tons, jointly prepared for the period 2005 to 2013 by two government agencies, the Building Materials and Technology Promotion Councils and the Center for Fly Ash Research and Management. This waste is dumped illegally on vacancy sites, on the sides of highways, below flyovers, beside lakes and rivers, in the overlying areas and open stormwater drains. Delhi and Bengaluru provide a glaring example of this practice, commonly known as the fly tipping in Bengaluru. Construction and demolition waste is increasingly being used to encroach on a lake bed land for construction. These are the completion certificate of our project. So now candidate declaration. I declare that dissertation report presented here for Master of Engineering entitled Assessment and Experimental Analysis of Construction and Demolition Waste into Construction Soil is my own work conducted under the guidance of Professor Rahul Parmar. I further declare that to the best of my knowledge this dissertation report does not contain any part of work which has been submitted for the award of any degree either in this university or other universities deemed university without proper citation. Now the acknowledgement. I am highly indebted to Professor Rahul Parmar. He is a professor of civil department and a head of and head of our department is Dr. Vimal Patel for their guidance and consistent supervision, as well as providing necessary information regarding the project, and also for their support in completion to this project. I would like to express my gratitude toward our parents and member of civil department of BS Gardi College of Engineering and Technology for their kind of cooperation and encouragement with help us in completion of our project. Our thanks and appreciation also goes to our college in developing the project and people who helped us out without their abilities. So table of contents. The first is certificates, then candidate declaration, acknowledgement, table contents, list of figures, list of tables, abstracts, literature reviews, summaries, construction and demolition waste, 4 hour of construction and waste, work plan, test plan, canvases, conclusion, references, etc. A list of figures, okay, and list of tables. So the first one is the abstract. Construction and demolition waste. Construction waste are beneficially because it is reduce the cost. Various method and experiments like standard protocol test, California bearing ratio test, UCS stress are done by our seniors. Now in this project we will analyze and discussing for the application of construction and demolition waste for improving the performance of subgrade layer in the highway. In construction demolition waste we have mainly focused on the plain cement concrete, plaster waste, bricks, soil, which are a major waste in construction demolition waste, and how to use this in a subgrade layer to achieve the strength and economy while considering the environmental factors. The literature reviews. The first literature review. The title of this literature review is Construction and Demolition Waste Management. The author of this paper is PM Markandeya Raju, Maharaja Vijayaram, Gajapati Raj College Engineering. References are a Muller determination of the composition and construction and recycled aggregate, Almenda Country Waste Management Authority. Outcome of this paper is a construction and demolition waste is characterized by large variation range of composition as well as physical properties. Main field of application construction and demolition, unbounded system like fields and embankment. Second literature review. Title of this paper is Demolition and Construction Waste Characterization for a Potential Reuse Identification. Author of this paper is Lena Maria Osorio, June Manuel, Beltran Montoya. References given is a website link. Third research paper. The title of this paper is Soil Improvement by Fine Fraction Residues from Recycling Construction and Demolition Waste. Author of this paper is BGS Visaprasad Joga, Jayaprakash Reddy, Teluri Rajesh, YY Yaswant Kumar, K Ram Mohan Reddy. References of this project is Arabian Journal of Geoscience, and outcome of this paper is a liquid limit and plasticity index of the treated sample decrease with an increase in construction and demolition waste for the all percentage, as construction and demolition waste is a non-cohesive and pozzolanic material. Fourth research paper. The title of this paper is Estimation of Construction and Demolition Waste in Building Energy Efficiency Retrofitting Works of the Vertical Envelope. Author of this paper is James Santa Cruz Estrongi, Mercedes Del Rio. References and outcome of this project is heat loss in building. Fifth research paper. Title of this paper is Stabilization of Expensive Soil Using Construction and Demolition Soil. Author of this paper is Parimal Kumar, Vivek Shukla, and Kiran Markle. References ASTSD 3242 Soil Classification, IS 2720 Part 13 Direct Shear Test, Part 3 Specific Gravity, Part 4 Determination of Grain Size Analysis. Outcome of this project is the future utilization of construction and demolition wastes in stabilizing the black cotton soil has been examined. Here the soil has increased GI value in A75 subgroup as per TO soil classification system, which proves a low quality of soil considered stabilization. Sixth research paper. The title of this paper is an optimization model on construction and demolition waste quantification of from building. Author of this paper is a Southern K. Ghosh, S. H. Halder, S. Chatterjee. References are Butria Stephania, Stefan 2050, Environmental Impact Assessment of Recycling and Construction Demolition Waste. Outcome of this project. The demolition and renovation works on which the research was conducted give us a valuable insight ranging from the components to be included in the mathematically model to the evident cases of waste produced on site. Seventh research paper. The title of this paper is the Environmental Impact Assessment of Recycling of Construction and Demolition Waste. This author of this paper is Stefania Beutra. References are Department of Environmental Engineering. Outcome of this paper is the goal of this PhD was to provide an assessment of a potential environmental impacts related to construction and demolition utilization. 8th research paper. Title of this research paper is Managing and Construction Development Waste. Author of this paper is the TEMA Research Group. References are Simons Limited, Construction and Demolition Waste Management Practice and their economic impacts. Outcome of this project is that it has been difficult to obtain sufficient and standardized data for all of the countries, especially in the recycling rate. In addition, as it has been shown, the generation rate in ton per capita differs among countries due to the difference in building tradition, economic activity. Ninth research paper. Title of this research paper is a Construction and Demolition Fire Safety Plan. Author of this paper is the University of Alberta Facilities and Operations. References is a for safety@alberta.ca. Outcome of this project is outcome of this research paper is a fire safety plan is required for each construction or demolition project within university facilities. Okay, the summary of this project. The first one is introduction. Soil is a non-renewable and limited natural source. In this construction industry, the recycle rate of construction and demolition waste is assumed to be low. The worst cases In the worst cases, construction and demolition waste soil are treated as a waste. From a financial perspective, soil is a significant part of construction costs, representing between 5% to 60% of the capital cost of infrastructure of project. The keywords: construction soils, construction and demolition waste. Construction and demolition waste. What are construction and demolition waste? Construction and demolition waste are generated when buildings and civil engineering structures are built. New building and civil engineering structures are built when existing building and civil engineering structure are renovated or demolished. Construction and demolition materials often contains bulky and heavy materials such as concrete, soil, wood, asphalt, gypsums, metal, bricks, glass, etc. 4R of construction and demolition waste. The first is reduce. Source reduction reduce like recycled material use, energy use and waste generation. While reuse and recycling are important methods to sustainably manage waste once waste has already been generated, source reduction prevents waste from being generated in the first place. The second one is the reuse. The major benefit of reusing material is the resources and energy use that one saves avoided by reducing the production of new materials. The third one is recycle. Many building components can be recycled where markets exist. Asphalt, concrete, and rubble are often recycled into aggregate or new asphalt. The fourth one is the rebuy. Rebuy, buying used construction and demolition materials are recycled contact product for use in new construction can affect as below. Lower construction and renovation costs while maintaining building function and performance. Unsold materials collected from reuse recycle programs will be used again the manufacture of a new product construction. Our work plan, objectives, materials, methodology, implementation. The first one is the objectives. The increased waste in construction industry causes a major problem for disposal operation. The waste material from construction activities are heavy in weight and occupy more storage space. In India, out of 40 million tons of solid waste generated, construction waste make up 25%. Concrete and masonry waste can be recycled by sorting, crushing, sieving into recycled aggregates. These recycled aggregates can be used to make concrete for road construction and soil stabilization, etc. Materials: black cotton soil, construction and demolition waste, concrete and aggregate. Methodology: collection of materials, determination of properties of materials, conduct test blading, analysis, and then conclusions. Project implementation: this is the figure of project CV analysis. Collect the C&D waste and find the initial properties. Conduct the sieve analysis test on the soil to determine the void ratio of soil particles and also find the initial characteristics of soil. Find the different combination to achieve the best proportions. Add the additives to the soil in the calculated proportion to improve the strength of soil. Find the properties of composite soil and compare those values with initial characteristic of soil to find the improved strength of soil. Test plan. Uh, this figure shows our test plan. The first one is the scope. The scope of this project to precise and customer requirement and budget. The test is analysis and CBR test. Risks and issues. The lack of team member. The test plan. The first table is shows the human resources. The first human resources and member of members, and second one is task. The first is a test manager and his task is to manage the whole project and define the project direction. The second is a tester, which is through Nirav and Yes Kumar. Their task is to identifying and describing the performing the tests. The second table shows the test resources. The first resource is construction and demolition waste, and its description is a construction and demolition waste like soil, concrete, bricks, etc. Second resource is a soil test laboratory. To description of this description of this resource is to perform the test on construction and demolition waste. Third resource is a IS code. IS code will identify and describing the test in brief. IS 2720 and IS 1498. Test plan. This is our site pictures. These are our site pictures. Canvases: AEIOU summary, empathy canvas, ideation canvas, and project development canvas. The first one is a AEIOU canvas. Environment: land pollution, water pollution, interaction, owner to engineer, contract to engineer, engineer to labor. Objects: miller, tractor, JCBs. Activities: broken roads, crushed in slab, moisture slab. And users: engineer, contractor, operator, etc. the second one is empathy canvas. The first one is users. Industry and construction sites will use are the users. Then stakeholders, government, environmental engineering, industries. Happy story, treating demolition waste we can reuse. And the sad story, proper designing and optimization is a not carry out at initial stage for a space and process time. Canvases. The third one is ideation canvas. Peoples, engineers, lab technicians, activities, selection of industry, selection of construction sites. Context is improve the quality of soil, reuse of construction waste, props, chemicals, waste construction samples, and sieves. Purpose is this is a product development canvas. The purpose is a reuse of construction soil, reduce the construction and demolition waste. People are engineering and lab technician. Product experience, primary experiment are going on. Experiences share after some modification. Functions is possible removal of waste in soil. Features the experimental analysis of construction and demolition waste into construction soil. Components, chemicals, construction waste, and sieves. The conclusion of this project: B% type of soil proportion high strength of CBR values. A% type soil less value of CBR. A% type soil sample not accepted CBR value. B% type soil sample accepted for road. C% type soil sample accepted for subgrade soil subbase of road. UCS test result is acceptable. CS strength parameter improvised by bricks. Compressive strength improved by concrete. References: Municipal Solid Waste Environmental Problems, GPCB Guidelines, CPCB Guidelines Application of Construction and Demolition Waste for Improving Performance of Subgrade, Training Manual on Construction and Demolition Waste Management in India, Review on the Role of Solid Waste Material in Software Engineering. Thank you.